Hello everyone. Today I am going to present our project on plant disease detection using a convolutional neural network. The main objective of this project is to build a deep learning model that can identify whether a plant is healthy or affected by a disease using image data. For this, we use powerful frameworks like TensorFlow and Keras to design, train, and evaluate our model. First, we start by connecting Google Drive to our Colab notebook so that we can easily access the dataset without repeatedly uploading files. After that, we perform data visualization to understand how the plant images look, including both healthy and diseased samples. This step helps us gain better insight into the dataset. Next comes image preprocessing. In this step, we check the dimensions of all images and resize them to a fixed size for uniformity. Then we convert the images into NumPy arrays and normalize the pixel values to improve model performance. After preprocessing, we check for class imbalance to ensure that all categories are fairly represented, which is important for building an unbiased model. Once the data is ready, we split it into training and testing sets. We also apply one-hot encoding to the target labels since this is a multi-class classification problem. Then we move on to building the CNN model architecture, which includes convolutional layers, pooling layers, and fully connected layers. After designing the model, we compile it using appropriate loss functions and optimizers. The next step is model training, where we train the model using training data and validate it using validation data. During training, we monitor performance by plotting accuracy and loss graphs for each epoch. This helps us understand how well the model is learning and whether it is overfitting or underfitting. After training, we pre-process the test data and use the trained model to make predictions. Finally, we visualize the results by comparing the original labels with the predicted labels to evaluate the model's performance. The main significance of this project is its real-world application in agriculture. With the global population expected to exceed 9 billion by 2050, food production needs to increase by 70%. However, plant diseases currently reduce crop yield by around 40%. By converting this model into a mobile application, farmers can easily detect plant diseases using their smartphones and take early action. This can greatly improve crop productivity and support the agricultural sector. In conclusion, this project shows how deep learning and CNNs can be effectively used to solve real-world problems like plant disease detection and contribute to smarter and more efficient farming. Thank you for watching.